Hey everyone, today we're looking at a Beats. Beats, it's red, can't even read it. Beats Bluetooth speaker. This one seems to have run flat and won't charge. Interestingly enough, this is an Apple product. Now, I was having a look in the charge socket. At first glance you might think, you know, these are all micro USB connectors usually, but it didn't look quite right, so I looked under the microscope and sure as eggs this is a lightning connector. And then on closer inspection in the fine print it actually says Apple. So this is a Beats product red, in case you hadn't noticed. And when I plug it in, using an Apple charge cable, we get no lights or anything like that, completely dead, and charge current consumed is 0. So she's definitely not trying to charge. Let's see if we can get this thing apart in a non-destructive manner. Hopefully it's put together similarly to other styles of these. Usually I think the grill will come off. Let's have a poke and a pry and a prod and any other word starting with P that you can think of. I can get the get under the edge of that there. Does it come loose? A little bit of movement there. I'm thinking maybe this comes off. What's under there? Could this whole panel come off perhaps? No, I can get under the rubber, but I don't want to peel the rubber off if I can avoid it. Should we try the other side? That grill flexes as well, but it's not letting go. I usually like to give it a go before I go hunting for the answers, just see if you can figure it out. But sometimes it's just easier to look up how to disassemble. Someone else has done it before, and it could save you breaking things. Looks like it's fairly well glued together. Good on you, Apple. But we need to peel this off. If I can get it so that the double-sided tape comes off with the rubber, it's a little bit cleaner. Now I believe that's as far as we have to go. Get these two screws off, and then this red shield is kind of stuck down, but we have to pry it off from there. That should come off around the rubber seal. Well, I may remove this completely. Well, it may not be possible, as this flap is held in via a little piece that goes down into the plastic. I don't think I want to try and pull that through, so we'll work around that. Wedge some things up under there to try and help keep it away from the case. Okay, I seem to have caught a plastic rim. I'm not sure if that's supposed to come with it or not. Try and separate that. No, the plastic rim does come with it. Okay. Aha. It seemed to let go a lot more on the corner than it did on the straight. So I think we need to focus our attention right on the end. Let's get into that one. Oh, maybe that was a fluke. Surely it's letting go. There we go. Here we go. There is actually clips. Here's a clip. So I guess ideally you're prying up under here and pulling outwards to try and release that clip. Pulling out so that it'll lift up. Got one there, one on each end. So 3 on the sides and 1 on the end. Probably the same on the other side of the unit too, over here. And we've got some kind of cover. And that's pegged into these holes as hiding screws down in there. So that just peels off as well. Now, is there feel for the holes? Probably one in the middle. Yeah, definitely a hole in the middle. Now to get this section out, what do we have to do? It's very stuck in there, but you got to get in under this edge and pry it up. Like that. And I win the battle. Now it comes apart. And we have, you can see down in there, some kind of cable on the big flat flex cable there, and a multi-stranded cable. Let's try, probably better that way. Here we go. Aha. What do we want to do first? We want to get an idea if the batteries are okay. Now it looks like the main board is under the speakers, and here's our one cell, is a two cell battery. 18650s it looks like. So I wonder if this board does all the charging management as well. Maybe we don't need anything on there, but it's all done in typical Apple brown PCB solder mask. And what's going to hold that flex? Can I unplug the flex at this end, or is it easier to do it at that end? Might try it at this end. So it looks like we'll flip that edge up and slide that out. It is glued down, so we'll just have to remove the glue. See if we can gently snip away the glue. quite often somewhat brittle, so you give it a squeeze and it tends to just come off pretty easy like that. Being the type of connector it is, it pushes down into the holder to lock it in. So I usually just get a little flat screwdriver underneath, give it a little lift like that. You could probably pull up on the wires, but I just like doing it that way. Let's take a measurement of this connector here then and see if there's any voltage on that. And I don't know which pin's which, but we'll just start left to right. So we have nothing on there, nothing on there, nothing on there, nothing on there. It's no good. It's probably positive and negative on the outer ones. They are fatter, and then data on the inner ones. If I had to guess, Apple's over-engineering a Bluetooth speaker, because every other Bluetooth speaker in the world just has straight DC power off the pack. This looks like it's a battery management system. But I guess if you've already developed something that works in your phones and tablets, you may as well stick with it. I just hope that the battery management IC hasn't locked out the pack. Because if that's the case, I have no means to unlock it. The batteries don't make contact with this board directly by the look of it. They go through here, and it's all handled on this board here. So I'd like to know what state the cells are in. I might just disassemble this and see if we can't probe the cells directly. Screws out, lid off, battery loose. Maybe I'll take the other side out. It won't take long. Now she's all wrapped up under the plastic, but it's not going to be a huge amount, I'd imagine. I won't get too carried away. You can just peel the end open like that, and same again there. So we can probe each end of the cell that way. There's no point gaining access to the BMS board, but we can at least get an idea as to whether the cell has any voltage in it. And that's at 3.3, so that's alright. That shouldn't have shut down. And the other one's at 3.4. Maybe they just need to be brought back up to 3.8. I'm just going to try putting voltage directly onto those pins, and it may start charging. It may not, but it might wake it up. But I don't know which one's positive. How do you figure that out? Well, let me show you. Usually, ground is connected to a large metal plane of some sort on the board, but we also have capacitors. We can see negative being the black mark on the cap. So one of those outer pins should connect directly to this, and that would be our negative. And then we stick our probe on there, and so the one on the right should be our negative. And we are negative on the right and positive on the left. And it's not working. No, it's not drawing any current. So I can probe this end and get the total pack voltage. So I'll see if I can directly charge at 6.8 volts right across it. Alright, let's rig this up. So with a lead attached at each end, we are pulling 150 milliamps at the moment. I'll trickle them up to closer to 3.8, 3.9 and see if the BMS is happier that they're not below a certain threshold, and that maybe it'll turn on and give me an output. I'm not always been successful with laptop batteries, but let's hope this BMS isn't as fussy. Alright, it's been a couple of hours. We've got up to 4 volts into these cells total. 8 4 volts each, 8 volts. Let's clip it back onto the board and see if it works. Let's, out of curiosity first, we'll check we have any voltage at the connector, just in case it woke up after reaching a certain level. And still nothing there. That doesn't mean anything. So let's plug it on the board. We're going to need to try and charge it, aren't we? Let's just reconnect this part first. A little bit fiddly. And we can, because I haven't mounted the batteries back in the shell yet, and may need to plug in a charger in order to reactivate things. And I don't see any lights. Either the pack shut down or the board is not activating from the USB. It's not. I wonder if it would run off the USB if it was working. Now we're going to have to fault find the USB input. I think maybe this larger connector with the 4 wires, I think, just goes to the headphone socket. I think it's just the left and right speaker connections, and the rest of it's managed on this flex. Next step will be to see what we got for a charge control circuit there. Let's check that the voltage from the charge cable is making it to the main board. So where's ground? Probably that's marked V, maybe because these two are joined together at this end. So I wonder if that's V and that's ground. I wonder if this is also ground. Let's probe the two end ones. And I've got nothing. Let's probe that one and that one. Nothing in the third one. Nothing in the fourth one. Nothing. Nothing. So no potential differences there. Let's see if the shield on the cable goes through to the board here somewhere, to see if that's shielded to ground. Ah, yep. So that connection there, that spot there is ground, like I thought it might be. So this end one is ground, and that one is not. Okay, well, it's not going to charge if there's nothing getting through this cable. So it's not going to talk to the battery, it's not going to function in general. So let's look over this side where the charge socket is. I probably should take this board right out and see what's on the other side, to be honest. But this looks like a possibly an inline choke for purposes of data line filtering, maybe. But I wonder, there is test points around here, so surely at some point we have that's our input voltage. Let's check for ground. So that one's a ground, so we can reference that. Compare that one to, say, that one. We have nothing. Nothing on the inductor. Anything on the diode? Really nothing anywhere. I wonder if the charge connector's broken off the other side of the board. Let's take this board out and have a look. I mean, it plugs in nice and snugly, but it could just be held in place by the fact it's sandwiched in the case. So yeah, let's take this board out. So here's the board. What does it look like? Dry joints around. It's just a shadowing of the flux on the board, I think. Anyway, let's flip it over, and what have we got? Ooh, it's a module. It's just a little module that plugs on there with the charge socket. And what have we got here? A TriStar chip in a Beats Pill Bluetooth speaker. Nice. I bet that's gone bad. I think maybe I've got one of those. Shame I don't have a TriStar tester. But it's not drawing any current at all. I wonder if they use other iPhone ICs, like, what's the next one in line with that? I don't work on iPhones. Is it anyway, that's our connector for the headphones, I guess. So I guess is this connector still attached to the board? It hasn't been knocked off. It looks fairly solid. Okay, I bet is that just glued on? It looks like it's just glued on. I've got this epoxy holding this little plug-in board in place. Of course, it's going to be sandwiched when it's screwed into place, but obviously a little bit of shake proofing doesn't hurt. All of those pins still look attached though. Slice that off. It's fairly soft. You want to be careful how much force you're putting on things like this. You also want to be careful there's no SMDs under it. That'd be right, wouldn't it? End up snapping components off the board. But yeah, if you put too much force on it and then it lets go, and you end up shooting into, say, a component on the board like this one, you want to avoid doing that. That can work quite well. If you can grab a piece of it without cutting through it, you can get quite good leverage. So once you've got a grip on it, just a slow, gentle pull, just enough to allow it to keep moving off the board. You don't want to pull too hard or too quickly, because it'll probably just break, and then you've got to grab another piece. But at least nice and slowly, it'll take all of it with it. So now there we go. I'll just push it through. There we go, and we're off. Whoops. That won't be anything important. What's on the other side of that? It's just going to be like probably ground pass through or something. Maybe nothing. We shall see what's going on there. A little IC there. Let's check these pins. They all look intact. Solder didn't look as good on that side, but they seem to be hanging on, so that's all right. So with it plugged in, we only have we got 5 volts on here, and we've got 1 volt on here. So I'm not sure what pins they are of the TriStar. Probably can't call it TriStar on here though, they probably call it something else, but it's a 1610A3 chip. I'm just going to call it TriStar. And I've got no voltage anywhere else. And then on this side, I believe this is some MOSFET. I've got 5 volts on here, and nothing on here. So we've got at least those 3 balls on this side of the chip go to this trace. It's quite a big trace, and they were scratch, easy scratch off a little bit of mask there, probing from there to these pins on the connector, and it goes to all of these pins along here, most of this side. So that is almost definitely going to be, once there's communications, I think, with TriStar, then it's going to enable that FET or that IC, whatever, to pass current. So I mean, I guess that could be faulty. It might not be TriStar. Let's replace TriStar. I've put a coin over the edge just to cover the socket, because it's a bit of plastic that sticks out slightly. I don't want to melt the edge of it. And it also kind of holds the board down a little. Give me a chance to use my new tip. I finally found some finer tips, which is quite nice. Tin it for the first time. Smooth those out. Need more heat. Grab a new one. I tend to save them if their job, if the replacement doesn't fix the problem, so you can reball them later. But I don't get a lot of iPhone jobs anymore, so and nice and sticky. Might switch, not so pointy tweezers. Need a little more, little flux there. Oh, and I'll just get it stuck to everything. And she's down. Is it gonna work? Nicely flat. What I did find is that the ground on here is not the same as this ground, because I was hanging on to this to support the whole assembly when I was probing here earlier, and could not get the right voltage. So just be aware of that. If something doesn't seem right, reevaluate where things sit and how they might be hooked up. So let's plug it in and see if we have any change in our voltages there. And survey says, I probably should have checked for shorts under the chip first. So we still have our 5 volts here, actually 4.6. Oh, we had 1 volt there before and now we have 3. That's promising. We have our 5 volts before that possible MOSFET control IC. Ah, we have 5 volts after. So now we have 5 volts being sent to the board, the main board. That's fantastic. Let's plug it in and see if it charges the battery. Hopefully it brings the battery back to life. And I still don't know what this, I thought it might be for speakers. It could be on an isolated output to the speakers. I can't see a connection between here and the speaker directly, but we'll plug it in anyway. It's all part of it. You never know. Make sure that's seated. I need to glue that back on. Don't let me forget. We'll need to put some more glue on that. And plug it in. 300 milliamps, 400 milliamps, and it just turned on. How can I a bit over gently? I want to lights. Oh, the joy, the joy. And it's blinking, which means it is charging. Oh, it's now pulling 1.37 amps. Well done. Battery pack is not bricked. I'm going to let that charge for a bit and make sure it's okay, and we'll reassemble and test. Cool, so we're up to the last light now, making progress. Let's put it all back together and make sure it makes sound. Better not forget to glue that board in. Cut off a small piece of hot glue stick, and we'll just encourage it into place with a little hot air. Probably should have put this back in before I got carried away and put the battery in, because that cable goes over the top of this board. I don't think I can flex it enough out the way to squeeze this in. Right, almost there. Let's get the flex back in. There we go. And we gently sandwich that back together, folding cables in a way that doesn't encourage the battery connector to pop off. I mean, it might. Maybe I should hot glue that, because when I squish that up, it is going to be possibly pushing up on those wires, and they're very stiff wires, and it could unclip things. It had a little bit on both sides, so I better do both sides. Good as new. Will I make it before the SD card fills up with data? Can we reassemble this in time? Got plenty of battery left. Okay, make sure no cables are squishing where they shouldn't. And that should just click back into place, I guess. Oh, let's see if it turns on before we fully seal it up. Well, that's promising. Let's pair with it. Hey, the light went off. Is the thing still on? That's just an indication of battery. Let's hold the button down. Oh, okay, so it was on. Just doesn't leave the lights on all the time. Cool. Ah, Beats pill. Okay. Pairing with Beats pill. There we go. There we go. Fantastic. Got it with a small fight. Okay, a couple more screws to go. One in there. One in there. And line it up and stick it down. And I've got that twisted. Hang on. There we go. Perfect. Right. One last test, make sure it charges. Hey, how about that? And there we have it, folks. One TriStar repair on a Beats pill Bluetooth speaker. I hope that was valuable for everyone watching. And maybe it'll help you get one of these things going again. No need to doubt the battery pack right away, which is good. I mean, usually the lockout circuitry and those won't kick in until if the cells were like below a couple of volts, I think. If that chip loses voltage, it'll lose its memory, it'll do all sorts of things. So not a problem there. And at 3.2, I think was on the whole pack. Was it 3.2? 3.2 per cell, so 6.4. Definitely discharged, fully discharged, but not enough to be a problem. So if you see across your pack like that it was about 3.2, 3.4 per cell. You don't need to write the pack off right away. All for the sake of a little TriStar. Thanks for watching.